Hello, Namaskar, Vanakkam. Welcome to CBSE with Sudhir, where we are covering Class 8 Science for you as per the Curiosity NCERT textbook. Today, in this particular video, I'm going to be teaching Chapter 8, which is Nature of Matter, talking about elements, compounds, and mixtures. What exactly is the difference between elements, compounds, and mixtures? This is this textbook, Curiosity, for Class 8. And as I said, this is chapter number 8. I hope you have already seen the particulate nature of matter chapter explanation video, because the three chapters, chapter number 7, chapter number 8, and chapter number 9 are interlinked. So you need to see it in order to be able to understand it properly. Let's get started. Now, what exactly is matter? We discussed that in the initial chapters also, in the early chapters of science also, but let's do a quick recap. Matter is anything that has mass as in kuch wazan hai. I wouldn't say weight, because weight is also linked to gravity, right? But mass, essentially the way we understand it, and takes up some space. So it could be anything. As we said, matter is this block of wood or a stone that I showed you, or air, anything that takes up space and also has mass, such as the air we breathe, the water we drink, and the food we eat, right? Most things around us are not single substances, but are mixtures of two or more substances. This is what we are going to be talking about in this particular chapter, that all the things that we see around us are actually some kind of combination. To give you an example, bhel puri khate hain, right? Now it is a combination of puri and some kind of bhel, right? So only when you mix it, now what is that? That is a mixture. Yummy, muh mein pani aa gaya, right? So that is what we are going to talk about in this chapter. Now, when two or more substances like this, from the pink bottle and the yellow bottle, they are mixed in a bowl and then they are mixed together, that becomes a mixture. So when two or more substances are combined in such a way that each substance, the pink substance and the yellow substance, retains its own properties, it is a mixture. It is able to retain its properties. There are some exceptions, but in largely the mixture, the two substances will be able to retain their own separate identity. Okay, look at it this way. When I take examples, you'll be able to understand it better. The individual substances, for example, here, the blue and the green are coming together to form some kind of a pattern, but they are still distant from each other. You can make out this is blue, this is green, the two are different. So the individual substances in a mixture are called its components. So please remember this word. This will be the definition of a component. And they do not react chemically with each other. This is the main element, main aspect as far as a mixture is concerned, that the two components that come together to form the mixture, they do not react chemically with each other. Okay. Now, there are two types of mixtures. The first one is the non-uniform, or what is known as heterogeneous. Homogeneous is uniform. Heterogeneous is when they are different from each other. For example, something like this, a salad which your mother or father prepares for you. This has onion, this has sprouts, this has some kind of dal, some kind of chana, different kinds of things which are mixed to make the salad nutritious and healthy for you. So the components are visible to the naked eye or a magnifying glass. So you are able to see the different components ki kya kya mix kiya gaya hai. Gajar hai, different kinds of coriander, etc. there. So they have all been mixed together and you are able to see it with the naked eye or with a magnifying glass. Example is sprout salad, where you can see the chickpeas and the onions distinctly. Okay, so this is one part which is the non-uniform or the heterogeneous mixture. The second one is the homogeneous mixture. Now here what happens is that the components are distributed so evenly, almost in equal measure, that they cannot be seen separately even with a microscope. Even with a microscope, you are not able to see it differently. For example, when sugar, like I showed you in the last video on particulate nature of matter, where when the sugar is mixed completely with water, you may not be able to, if it is completely dissolved, you will not be able to see the sugar particles at the bottom. It would have got completely dissolved. That is, all those things which would have come in the spaces, the interparticulate areas between the water atoms. So you will not be able to see that when the sugar is completely dissolved in water. What are alloys? Now here you need to pay attention. Now these are uniform mixtures of two or more metals, or a metal and a non-metal. They are mixed uniformly and one cannot see the individual substances. So when they are mixed together, you cannot say ki ye metal or ye non-metal alag hai. You will not be able to distinguish one from the other. So the examples of that, the most common example is the stainless steel, the spoon that you use while eating, the plate that you use while eating. If it's a stainless steel plate, all of them, stainless steel is an alloy of iron, of nickel, chromium and carbon. All these four components, carbon in small measure, but mainly these three are used to manufacture. They come together to form this alloy called stainless steel. Then brass is another alloy of copper and zinc. Then bronze, which is used in metals, copper and tin. So these are alloys. You need to remember the alloy name and what are the components, what are the metals, non-metals which are used in order to make that alloy. You need to remember. Sometimes you can get question on what does bronze consist of, copper and tin. This is copper and zinc, right? So you need to know these things, which are very important from an examination point of view. Now, a small piece of information. Mishra Loha was the name given to the mixture of two or more metals that had properties distinct from its constituent metals. That is, the metal will behave in a particular way. The metal will behave in a particular way, but when it becomes an alloy, it behaves in a slightly different kind of manner. The character becomes slightly different. So Mishra Loha was the name given to the mixture of two or more metals that had properties distinct from its constituent, that is, the things which came together to form that. Ancient Indian texts such as Charaka Samhita, Sushrata Samhita, Rasaratna Samuchaya, Rasa Jala Nidhi, etc. mention the use of alloys for medicinal purposes. Okay, not very important. Now, just want to tell you, if you are looking to buy the question bank, because despite putting it out in almost every other video, because I want so that people don't keep sending me individual messages over Instagram or email, I'm telling this to you in these videos so that this is a general information note, nothing to do with me. I don't get anything. This is for your benefit, which question bank to buy. So instead of buying a mediocre quality question bank, all I want is so that you invest in the good quality question bank. The one that I'm suggesting is the Oswald Books question bank. I'm giving the link in the description box how you can buy it on Amazon. So follow that link so that it takes you directly to that page on Amazon where you can choose which book to buy. Alternately, what you can do is to go to oswaldbooks.com, click on class 8, and there, before you make the purchase, use this author coupon code Sudhir10 to get additional discount and save money for your parents. So that is something which you can do. So either you do this, follow the link given in the description box for Amazon, or you go to oswaldbooks.com, and don't forget to use this coupon code in order to get this thing. Why do you need a question bank? Well, you can follow the explanation videos here, take down notes, then you don't need to buy the question bank. But if you buy the question bank, you get notes. Where is the question bank out here? I don't know where I have kept it. I'm able to see. Where has it disappeared? I can see this is the one for social science out here. I can see that. I don't know where I have put. Oh, here it is. Class 8, Purvi. This is the question bank for Purvi. Similarly, I've got for science curiosity. I've got one for English as well. So you will have notes. You will have all the answers to the NCERT questions. You will have lots of extra questions and answers for practice before the examination, and you will have 2 full 80 marks practice test papers in the in this particular book, which is quite fat. It's almost 304 pages, and you will have lots of diagrams, the activities which are explained. You will also have these kind of mind maps also given, which will make it easier for you to remember. I mean, somebody asked me, sir, also give the mind map. Itna kaam to tumko khud karna padega. मैं spoon feeding नहीं करूंगा. I don't think at class 8 level your mother or father feeds you with a spoon at the dining table. You eat with your own hands, right? Similarly, certain things you need to do on your own, because when you do on your own, you apply your mind, you'll be able to remember and recall it better. So I will not give you mind maps in your own interest, because I want you to do it yourself. Okay, so that's as far as the information note is concerned. Let's move forward. Let's focus on this. Now, as far as air is concerned, the air that we see around us, it is a uniform mixture of several gases, mainly nitrogen, and we have studied this in class 6 and 7. 78% is nitrogen, then you have oxygen, and then there are the minor gases like argon, carbon dioxide, and water vapor. Okay, this is something which we are aware of. Now let's look at activity 8.1 in your textbook. Please keep the book open before you. The first thing is you fill a glass tumbler half with water. Okay, step number 1. Step number 2, you add a small amount of calcium oxide, which is quicklime. Okay, calcium oxide, you will get it in your chemistry laboratory at your school. Step number 3, then you use some kind of a stirrer or a spoon and you mix it completely. Okay, you create a solution of calcium hydroxide, which is lime water, which is created when you mix water with calcium oxide. Calcium oxide plus H2O, you will create calcium hydroxide. Okay, that's what you get. Now you use a funnel. You use a funnel to filter the solution until it is colorless and place it in a petri dish. So you do the funnel thing, and the water, I mean whatever liquid is there, it will come here. Okay, it will come in the petri dish. Now what you need to do is to leave it exposed to air. Now you just leave it open in the air. Don't do anything. Whatever has come down, you leave it open to air. Okay, just in a little while, every 20 minutes or so, just go and stir it so that it keeps moving. It's not static, right? Okay, now what happens is, the findings of this experiment, this activity 8.1 will be that the solution which you have in the petri dish will turn milky. How does that happen? Because this happens because the carbon dioxide which is there in the air reacts with calcium hydroxide which is there in the petri dish to form tiny insoluble white particles of calcium carbonate plus water. Calcium carbonate plus water is there. This is the reaction of carbon dioxide with calcium hydroxide which is there in the petri dish. CO2 plus calcium hydroxide forms H2O, that is water, plus calcium carbonate. Okay, and calcium carbonate is white in color. Okay, now let's move to activity to 8.2. So we have what have we learned in the last activity? In the last activity, we have learned that when carbon dioxide is in the air and that combines with calcium hydroxide, it leads to the formation of calcium carbonate, which is white in color. Now, the next activity is take a black sheet of paper. You will get those black chart paper, right? What you do is you put it near a window. You put it near an open window. Take a clean black sheet of paper, which is absolutely clean. Get it from the market. Place it undisturbed near an open window or in a garden for a few hours, about 3 to 4 hours. Examine the surface with a magnifying glass. Now, when you come back, you see the entire surface. How does it look? You will find that there are tiny shining particles which are there on the black paper. Why do we take a black paper? Because on a white paper, on a light yellow or a light cream paper, it will not be visible. On black, all these dust particles will be easily visible, black or dark blue kind of color. So the concept is that dust particles are suspended in the air. You know, when I look around here, I may not find any dust. I'll think, oh, the room is very clean. But actually there are dust particles floating in the air. What happens is that when there is a black color paper, it will kind of, on any paper for that matter, it will settle, and on black, it will show much more clearly. So this proves that dust particles are suspended in the air. They are considered pollutants and vary by time and location. So now when you see it with the magnifying glass, you will see all these dust particles on this black sheet of paper. Now, what are these pollutants that we are talking about? I mean, उनका नाम तो होगा, what are these pollutants? So the pollutants are basically carbon monoxide, there are ozone, nitrogen dioxide and sulfur dioxide. And the AQI, which we studied about earlier, the air quality index, AQI, जिसके बारे में काफी बातचीत होती रहती है whenever there is pollution, especially cities like Delhi. AQI is being spoken about quite a lot these days, which is why you install air purifiers in cities like Delhi during the winter months, November, December, Jan, February. Air quality index is a tool used to describe the air quality. So if it is 151, 200 and above, it is considered extremely unhealthy. That is, even if you are inhaling the air, it is equivalent to smoking 12 to 15 cigarettes at the same time. So these are the particulate matter, which are the pollutants which get deposited on that black sheet of paper. Okay, let's move forward. Now, have you subscribed? I hope you have, because I was seeing the data and I realized most of you who use the content are not subscribing. It's free. It's no cost to you. It's absolutely free. Have you shared the videos? That is something which I would want you to do. There are many students who are telling me that they're sharing the videos with their friends and they are liking it. It is being appreciated, which obviously makes me feel very happy. It makes you feel that, okay, you're doing something good to a larger community, absolutely free of cost. And if you have liked the videos, if you have liked the videos, press on the like button to express your appreciation. Okay, now let's move forward. We see a lot of things, दूध वाले को कभी, of course, आजकल तो सब पैकेट का दूध आता है, but sometimes, we, in the olden days, you'll say the दूध वाला would always mix water with the milk. In order to do what? So that he's mixing water so that he can sell that milk, whatever he has, to a larger number of people and make more money by mixing water. So when you mix water, the coffee or the tea that you drink will be very, very patla, it will not be proper milk. So what many people do is that we are selling pure cow milk, we are selling pure goat milk, we are selling pure buffalo milk, those kind of things. So what is the meaning of this word called pure, P-U-R-E? So pure substances, brands flash the word pure like this, pure ghee, right, in bold letters on products like ghee, milk, to say that there is no adulteration, that there is no milawat in this, there is no mixing of any other substance in this, that this milk does not contain water, it is directly from the cow into the bottle, no mixing of water. This ghee has nothing else mixed with it, it is pure ghee. That is what it is trying to convey. But in terms of science, the word pure actually conveys a very different meaning. Let's first understand what is adulteration, what I just now told you in the terms of a definition. Adulteration is an illegal process, means it is against the law to be mixing something. For example, when you are eating some dal, you suddenly may find a stone, you may crush a stone and you may feel very irritated, right? That is what the shopkeeper is doing, is to mix tiny pieces of stone so that the weight becomes the same, 10 kg, 5 kg, whatever you buy, but he has actually added stone. So it is the stone's weight and not the dal that he's selling. So the same dal he can sell more by mixing stone in it, right? And that is again something very unhealthy to the body if you are consuming stone, right? So what is adulteration? It is an illegal process of adding substances which are cheaper or of poor quality, like stones, like water in milk, etc., to another product, which is generally a food product. This is done to reduce the manufacturing cost, and it deteriorates, means it makes the quality poor. The quality of the product, it can also make the product hazardous to health, because if you consume too much of that stone along with your arhar dal, moong dal, white chana dal, whatever, it is bad for your health, right? So if you find something like that, you should go and complain to the shopkeeper that tum milawat karte ho, complain to the authorities and ensure that action is taken against that shopkeeper. Many people actually do that. But that was in regular life. But in the world of science, the word pure actually has a very different meaning. A pure substance means a substance that consists of only one type of particle and cannot be separated into other kinds of matter by physical processes. यानी कि अगर ये एक है तो इसमें से you cannot remove one If you are able to remove one, that means this is not pure. But if you are not able to remove anything, that means this is pure. So in the world of science, pure substance definition is different from the way we understand it in our regular daily world. Okay, I hope this is clear. Now, let's do the activity. It will be more clear. Let's break down water. Is it possible to break down water into hydrogen and oxygen? Yes, it is possible through a method called electrolysis. Okay, what are the steps? Fill a beaker, 2/3 of the beaker, you fill it with water, H2O. Add a few drops of sulfuric acid. Sulfuric acid helps in the conduction of electricity. Okay, without sulfuric acid, the electricity will not pass. So sulfuric acid is essentially to do that. Fill 2 test tubes. Now there are these 2 test tubes which are there with this water and invert them over the terminals. There is a battery which has been put inside the test tube, inside the beaker, and it has been connected to these 2 test tubes, right? Over the terminals of a 9-volt battery placed inside the beaker. Then you wait for 10 to 15 minutes and observe the gas bubbles. There will be these gas bubbles which will be formed in the 2 test tubes. Okay, this is what you will observe after about 15 minutes. Do this activity in your chemistry lab. It will be quite interesting. Now, what happens now? Bring a burning candle to the mouth of the first test tube. You will hear a pop kind of a sound. Okay, why does this pop sound come? It indicates that hydrogen gas has been formed. H2O has been split into hydrogen and oxygen. Water, which is H2O, has been split into hydrogen and water and oxygen. Then you bring the candle to the second test tube where oxygen has been formed, and you will find that that catches fire because that has oxygen. The flame glows brighter, confirming oxygen gas. So what is the finding? That water is a compound made of hydrogen and oxygen in the 2:1 ratio. It is H2O, right? So 2:1 ratio of hydrogen and oxygen. Now, there can be a question which is there in your textbook also. How do we know that these gases are not water vapor? If they were water vapor, they would have condensed back to form water. That's why they are not water vapor. They are split into hydrogen and oxygen. Okay. Now let's come to the basic thing that we started this chapter with, which is about elements. What are elements? Elements, this is something which you have all played with, right? I remember playing with my daughter with this. She used to have this with which to build a castle, right? So elements are the building blocks like this of matter and cannot be broken down into simpler substances. An element cannot be broken down further. They are the building blocks. They are the basic building blocks, right? Atoms and molecules, every element is made of identical particles called atoms. Atoms of most elements form molecules. Example, 2 oxygen atoms form 1 oxygen molecule, right? So this is the basic funda of atom, molecule and element. This is the correlation between them. So metals, for example, which are the metals? Gold, silver, iron are metals. Non-metals are oxygen, nitrogen, sulfur. Then there is another category called metalloids. Metalloids are elements with properties between metals and non-metals like silicon, right? So which have some properties of metals, some properties of non-metals, and therefore they are known as metalloids. The states of elements, out of the 100, which you will study in the periodic table in class 9 and 10, out of the 118 known elements, most of them are solids. Majority of them are solids. Only 2 are liquids at room temperature, mercury and bromine. These are the 2 which are liquid at room temperature. Okay, rest all of them are solids. Note that mercury is a metal while bromine is a non-metal. Now this is also another distinction which you can remember at this stage, but we will study about this in more detail when we do the periodic table chapter. Now, another interesting fact, now since we all use a mobile phone, you would be quite interested in knowing this, that there are as many as 45 elements which are used in the manufacture of a mobile phone. Now 45 किस चीज में? From wiring to battery, right, to the screen, to the motherboard, everything. So you use aluminium, you use copper, you use silicon, you use cobalt, lithium battery, gold, silver. Also, in fact, mobile phones also use a little bit of gold and silver in the manufacture of a mobile phone, as many as 45 elements, which I thought is an interesting kind of information. Now, next we come to compounds. Compounds form when different elements combine chemically in fixed ratios to form something new. Okay, now this is different from a mixture. You need to know the difference between compounds and mixtures, because that's what this chapter is all about. So they form something new and they combine in a fixed kind of a ratio. The key property of a compound is that a compound has entirely new properties different from its original element. And the most easy example to understand is hydrogen plus oxygen forming water, right? Hydrogen is a fuel. Oxygen supports fire. But when they form water, they actually come together to put out the fire, right? Isn't it quite interesting? Which is why the characteristics of water are very different from the two elements that come together to form it, hydrogen and oxygen. So water puts out fire, whereas oxygen actually supports fire. They cannot be separated by physical methods. You need a method like electrolysis in order to separate it. But by physical methods like using a magnet or using other forms of extraction, you cannot separate it. Like filtration or by magnetic method, you cannot separate a compound. How is salt formed? Now this is something very interesting. Salt, the formula is NaCl, N capital, A small case, C capital, L small case, NaCl. So sodium's formula is Na, chlorine is Cl, NaCl. Just see whether I can annotate on this. I was not really sure. That's why NaCl. This is the way it is written. Now, sodium is a soft metal while chlorine is a hazardous gas. Okay, just imagine these are the two things which are coming together in order to form salt, which is namak, up, right? So they combine to form a taste enhancing substance like salt. This substance is known as sodium chloride, which is made up of particles of sodium and chlorine in a 1:1 ratio, 1 of sodium and 1 of chlorine. They can be separated from water by the physical process of evaporation. That's how it is done on the sea coast. That is, you take the thing and then you dry it up, evaporation, and that's how you get the salt from near the seashore. Okay. Let's move to the third part. Let's move to activity 8.4, decomposing sugar. Now, the first thing you need to do is to gently heat a teaspoon of dry sugar in a boiling cube. Okay, you gently start heating it. Okay, just imagine, just see what really happens. The sugar turns brown, then chars into a black mass, almost looks like charcoal. Tiny water droplets appear on the edge of this particular test tube. Near the mouth, tiny water droplets emerge. So what is the concept? That heating causes the sugar, which is a compound, to decompose into its constituent elements, carbon, hydrogen, and oxygen. Now, hydrogen and oxygen are appearing as water droplets, right? And carbon is what is left at the bottom of the test tube. Okay. Now, let's do the final activity, activity 8.5, where we are comparing mixture versus compound. And this will actually make a lot of things very clear to you if you still have any kind of doubts. We are going to use iron and sulfur. So the setup is that we do a mixture first, where we mix 5.6 grams of iron filings, that is lohe ke filings. We are taking small iron filings, and we are mixing it with 3.2 grams of sulfur powder, which is yellow in color. So this 5.6 grams of iron filings and 3.2 grams of sulfur, we are actually mixing it together. What happens now? Sample B. This is sample A. What do we do with sample B? This is a compound. The first one is mixture. The mixture is heated in a china dish until a black mass forms, then ground into a powder. So we first heat it and then we ground it into a powder. Now, let's do a test. The first test that we do is to kind of take a magnet and bring it to that first powder where we have just mixed 5.6 grams of iron filings with 3.2 grams of sulfur, right? So when we bring the magnet there, immediately all the iron filings will get attracted to the north and the south pole, and immediately we'll be able to separate physically, and the sulfur will be left behind in the petri dish and all the iron filings will be attracted to the magnet, right? So sulfur is left behind, they are easily separated. This is what happens in the first magnet test. Now, sample B, which has been boiled, the magnet has no effect. The one which has been boiled, where the fire effect was done. Now, if we put the magnet here, उसने तो हाथ दे दिया है. It's not able to do anything because nothing is getting attracted to the magnet. The magnet has no effect. A new substance, iron sulfide, has been formed. It is no longer iron plus sulfur. Now it is sulfur, iron sulfide, which has been formed. Now we do a gas test. Adding hydrochloric acid. Hydrochloric acid is HCl. Okay. Hydrochloric acid is HCl. So sample A, it produces hydrogen gas, colorless, odorless, burns with a pop sound, which we saw earlier. The reaction is iron, that is Fe. Iron is Fe plus HCl. It forms iron chloride plus hydrogen. Okay, this is the reaction that is done. Okay, it comes when there is hydrogen is there, it comes with a pop sound. Pop, pop, karke ek awaaz aayega. So this is the first test, the gas test that we do. Then second test, the sample B. It produces hydrogen sulfide gas, which has a distinct, it's a dirty smell. Whenever we used to have that in the gas, in the chemistry laboratory, it used to smell like rotten egg smell. So the reaction for this is iron sulfide, because that's what has been formed in the petri dish, plus dilute hydrochloric acid. DIL is dilute. Concentrated is CONC, concentrated. It forms iron chloride plus H2S, this is hydrogen sulfide. So this is the second sample which is formed. So what the showing is that, what happens when you are doing a compound and what is happening when you are doing a mixture, the things are very different. So with this, I hope you are able to this thing, especially the one where magnet is able to separate physically, whereas you are not able to do the same thing when it is becoming a mixture. So that is something when it is becoming a compound, you are not able to do that. Where the chemical properties itself are changing. Now, just look at these 2-3 things at the end. Minerals and heritage. Natural solid substances found on the earth. Most are compounds like quartz or mica. Quartz is used in the manufacture of watches, etc. Mica is also an extremely expensive substance. But native minerals are pure elements like gold or silver. Gold or silver are pure elements, whereas quartz and mica are compounds, okay, where there has been one or two elements coming together. Then Dhokra art, this is very interesting, which is an ancient craft from Bihar and Odisha that uses molten brass or bronze, which are both alloys, as we studied before, to create nature inspired figures like this kind of a horse which has been created, which is some kind of a decorative or a gift item. Then graphene aerogol. Now this is very interesting because it's a modern wonder material made from carbon, and it is so light that it can actually be placed even on a blade of grass and it will not fall down. It is so light. It is the lightest material on earth and can absorb oil spills in the ocean. So this is another thing which can be asked in an MCQ or a true or false kind of a question. Okay, so just to kind of recap it at the end, mixtures versus compounds. How do you separate it? Physical methods like magnet. Compounds can be separated only by chemical methods, okay, like electrolysis, etc. properties, retains properties of the components, but in the case of compound, entirely new properties are there. They are very different from the individual components. Composition, it can be in any ratio, whereas these will be in a fixed ratio. Appearance, often non-uniform, whereas this is uniform throughout. So this is the difference in a tabular format, so that it becomes easy for you to remember also. With this, we come to the end of chapter 8. I hope I have been able to provide clarity on different concepts. Now what I want you to do is to please go through the chapter again immediately or at least tomorrow, so that then you can see, okay, all these concepts I have understood. Any doubt, come back to this video, see that portion, so that there is absolutely clarity. See, no longer you are going to get lollipop straightforward questions, definitions batao kind of a questions. You will be put more application based questions, so you should be able to relate it to daily life understanding of how what happens. And if you're able to do that, you will be fine. The concepts are not very complicated. Just go through the chapter again, underline all the keywords, and you should be good to go. Tata, bye bye. Thank you very much. I will now see you in the next chapter.